Sure. There's been many studies on how loss of the sea ice cover can impact other regions of the planet. Some studies were saying that we could have extended drought in the American West, so this would exacerbate some of these problems. Others have been saying that another possible outcome would be changes in patterns of storms and precipitation in northern Europe. It's one of these things that we're just starting to get a hold of now, and there's a lot of exciting research going on at the University of Colorado that I'm involved in, which is hopefully going to address some of these issues. One thing we have to remember is that losing the Arctic sea ice cover really does very little to sea level, because this is ice that is floating on the ocean. This is Archimedes' principle. He had this figured out thousands of years ago, that as you melt that sea ice, what happens is that it's filled with the exact amount of water that the ice had displaced, so it doesn't have any effect on sea level. What affects sea level, of course, is that you take water that was on the land and you put it into the ocean. And of course, the prime example of that is how the melt of ice sheets and glaciers are contributing to rising sea level. Even the little glaciers here, like Arapahoe Glacier here in Boulder, is melting down. It's actually contributing to sea level in a very small way. Well, the concerns with the sea ice, though, is a little bit more indirect, is that we think of what we're seeing is that Greenland's pace of melt is starting to accelerate, and Greenland is a growing contributor to sea level rise. But if we lose the sea ice cover, that's part and parcel of a warming Arctic. The quicker we lose that sea ice cover, the quicker the Arctic warms up. If the Arctic warms up quicker, that means the pace of ice loss from Greenland can be increased as well. So it's another example of the connectedness of the system, that sea ice loss itself doesn't influence sea level, but it can influence it through its impacts on other parts of the climate system, namely the Greenland ice sheet. We know that Colorado, for example, is influenced by El Nino and its brother La Nina. Now, this is just an example of natural variability in the climate system. Now, there are concerns that as we warm up the climate, the frequency or intensity of these El Nino or La Nina events may also change, which has other consequent effects on our climate. Another example would be what happens to the intensity of hurricanes. Now, that's not something that really influences Colorado, but there is concern that as we warm up the climate, hurricanes might become more intense. The argument there is that hurricanes feed on warm oceans, and the oceans are warming. So, another example of this connectedness of the system. This is what our projections are. If you look at how we make these projections is with these complex computer models of how the climate system works. There are modeling centers all over the world, and really some of the best centers are right here in Colorado, especially up at NCAR. Well, one of the projections that these models are coming up with is that what we're going to see in Colorado is that it not just becomes warmer, but it becomes drier as well. Now, that suddenly raises the specter of things like increased frequency of forest fires, because we have a drier climate. But what about that warmer climate? Things like bark beetles. Okay, now we've already had this great infestation of these mountain beetles, bark beetles, whatever you want to call them, in Colorado. Now, is this related to global warming? Are we seeing a signal of that climate change here right now? People are still grappling with that issue. In other words, is this infestation that we're seeing still part of a natural cycle, or are we starting to see the effects of this gradual warming? We're still not quite sure, but it is the sort of thing that we have to be thinking about, the sorts of things we're probably going to see in the future. I think there is definitive evidence at this point. As I mentioned, what our climate models are saying is that the region, Colorado and the rest of the American West, really should become both warmer and drier. Now, that's just what we're starting to see. That signal starting to firm up in the past 10 years or so. As many know, Colorado has been in the midst of a fairly long-term drought now. Now, there's still some people thinking that, oh, we're out of the drought. That was something that ended a few years ago. Not the case at all. Look at precipitation records from Denver right now. 2008 right now is shaping up to be one of the driest years on records. So it's still not quite clear, but in my opinion, we're starting to see the effects of this warming now starting to take hold. I think Colorado in particular has a very educated population on this because climate affects us so strongly or so clearly. We think about our water supply for drinking, for municipal use, for agriculture. It comes from melt of that winter snowpack. And we think of that winter snowpack as a convenient way of storing the water. The snow falls in the winter, and then it melts in the spring, and we can store it in our reservoir systems and pipe it out to the farmers. Well, we're starting to see that change. So that's an example of how climate really affects the people of Colorado. And I think because of this, Coloradans really have, I think, are a little more savvy on these issues. Not to mention that we have great universities studying these problems. We're very vulnerable to change. And so I think you're already starting to see now this thinking take hold, this recognition take hold that, oh, the next time we think about putting in a huge housing development, we think, well, wait a minute, maybe that's not the smartest thing to do. I'm really rather optimistic in terms of the whole climate change issue in that humans are remarkably adaptive. We'll live through this, but it's going to be a rough road ahead of us. The longer we wait to do something about climate change, the rougher that road is going to be. What we've immediately got to do is start changing our entire energy culture. Start thinking about our energy use and what we're doing to the planet. It's just remarkable to some people to even think that human activities, fossil fuel burning, could actually change the composition of the atmosphere and change climate. They can't accept that. They think it's such an outlandish thing, this huge planet of ours. Well, what we've come to realize is that this is a very small and fragile planet, and our activities are already having an impact on our climate. And the problem is, if we foul our nest like we are doing, we've got no place to go. Well, of course, we're going to be living in a warmer world. We're going to be probably living in a drier state as well. And that is likely going to force, for example, changes in agricultural practices. It's going to force changes in how we think of our water use, profligate water use. It's something we can't get away with anymore. Colorado, of course, is going to be a leader, continuing to be a leader in the development of alternative energy sources. For example, you've got the NREL lab just down the road. That's just one example of how Colorado is taking the leadership in this issue. One of the typical arguments you get from what we call the contrarians is that climate has changed in the past, and so why is this change any different? And what people have to think is that climate doesn't change all by itself. It's not like Harry Potter comes and flicks his magic wand and the climate changes. Something has to force it. The climate change has to be caused by something. We understand quite well how past global climate changes have occurred through periodic variations in the Earth's orbit about its sun. Things like volcanic eruptions. We go back millions of years ago to the very shifting of the continents through plate tectonics. Those are examples of past forcings on climate. But the forcings on climate change over the past century are very, very clear. We've actually changed the nature of our atmosphere by adding heat-trapping gases. You can't deny this. The physics behind this are actually rather simple, something you can learn in a high school lab. And you can't deny this. That's the problem. You have a hard time arguing against the physics. Some people say, well, how do we know that these grand climate models you have any validity? You use these to make projections of the future, and we say that it's going to warm up, we're going to have changes in precipitation, these sorts of things. How do you know these models are any good? Well, one very, very important test of these models is how well we can simulate the climate over the 20th century. So I mentioned previously this idea of these climate forcings. Well, if we give our numerical simulations, these climate models, our best estimates of the climate forcings through the 20th century, then we ask the question, can we actually simulate the temperature record over the 20th century? It turns out that we can. Okay? So in other words, a test of our ability to predict the future is if we can actually model what happened in the past. We can do that. we've got the right answer here. We know what's going to happen. Our earliest climate models were telling us that it is the Arctic where we would see the first indications of global warming and where those effects would be the most pronounced. Well, all through my years as a graduate student and up through about the year 2000, we were starting to see these strong changes in the Arctic taking place, but we weren't still quite sure what was happening. Were we still seeing just effects of natural climate fluctuations, or were we starting to see the effects of greenhouse gases in the atmosphere? I wasn't quite sure. But I think it was probably around the year 2000, right around the turn of the century, where I had an epiphany, where it became clear that the changes we were seeing were much too large and much too persistent to be explained away simply through natural causes. Now, what's happened in the past 8 years? Well, these changes that we've been seeing have gotten even more pronounced. The change, the signal that we're looking for has firmed up even more strongly. So again, you'd say even me, I would say even 8 years ago, I was sitting on the fence, so to speak. It wasn't clear to me whether we were seeing the effects of global warming or whether we were still within this realm of natural variability. Well, I'm a believer now. I got off the fence about 8 years ago, and I never got back on it. I think in terms of Colorado and our immediate impact, we of course have to think about just our personal habits. For example, our driving habits. Do we have to just run to the store every time in our big SUV burning a lot of fuel? No, we can be a lot more efficient in what we do. In terms of our other resources, our water resources, profligate waste that we see. Here we are trying to have emerald green lawns in a semi-arid climate, and a climate that's only going to become warmer and drier. We cannot go on in that direction. We have to be better stewards of our state, and being better stewards of our state means we're better stewards of our planet. We have to think of the footprint that we leave, just as if we would travel out into the wilderness and go camping. We're very careful about how we tread, the footprint that we leave. It's the same thing now when we have to think about our energy use. It's that carbon footprint. What is our impact on the planet's health? There's often this view that changing our behavior will cause this great economic hardship, this great economic upheaval to change how we use energy. And I don't see that at all. I see it as opportunity. There's already people and companies making money on this, and that will continue to happen. Americans are amazingly innovative. We've dealt with these sorts of challenges before. There's no reason why this has to be this great economic hardship. I see it instead as opportunity. One of the best examples of how the global community got together to deal with the problem is the issue of the ozone hole. The ozone hole over Antarctica. That was clearly due to this profligate use of what we call the chlorofluorocarbons. This was what would be in your aerosol cans. It was a case where we understood the chemistry of the problem quite well. In other words, we had a smoking gun. But once we saw that there really was a problem and we understood that it was us, humans, who were causing that problem, the global community got together and solved the problem. It's an example of how we can get together and solve these big problems, because global climate change, we think of the effect locally, but it's a global problem and it requires a global solution. We're of course starting to see a number of efforts by our government, local government, all the way up to the federal level, to start to address this problem with many different ideas, some of them good ideas, some of them bad ideas. But the key is that we're talking about the problem now, is that we seem to have been getting past the whole denialist part of this and accepting that there is a problem. To me, that is what makes me optimistic in that we've turned the corner on this problem. We've got a long, hard road ahead of us, but I think we see the path forward now. The Arctic is such a special place. I spent many summers and parts of some springs in the Arctic when I was younger, and got away from it for a number of years, but have started to go back now again. And I missed it so much by not being there. To many, I'm not alone in this view that to many the Arctic is almost more of a feeling than a place. Whether it invokes images of steel gray skies over Arctic sea ice or treeless windswept tundra, to many the Arctic is as much a feeling as it is a place. And that's true when I go up there. It's not just the sights that I see, this beautiful environment. It's how it makes me feel. It's this primality to the place that I think is unmatched anywhere on the planet. And that's why I'm so concerned about the changes that I'm seeing occur there. One of the interesting things about the Arctic, which is also disturbing, is that, well, we had always projected that it's there where we'd see the changes first, and there where the changes would be pronounced. The pace of the changes that are unfolding now have surprised us. They're occurring even quicker than we thought possible. If we look at the rate of loss of Arctic sea ice, we're probably 20 to 30 years ahead of schedule compared to what our climate models are telling us. We're not quite sure why this is happening, but what it is telling us is that the Arctic really is on the fast track of change. The Arctic has always been thought of as that canary in the coal mine, or that bellwether, and we're seeing that that is in fact the case. It's just that the canary seems to be chirping a lot sooner than we thought. The very strong sensitivity of a place like Colorado, the American West in general, a lot of that has to do with the aridity of our system. We're already kind of on the edge, precipitation-wise. Even a small change can have significant impacts in a region like this.